Okay, so it's family given this, I know, you just recap it. I'm use the data. Okay, you're given this data, and the we create a model, right? And the model like, and we train that with this data, right? The model I mean, your data train also. And this is you have a model which is a train model. And train one, like train model is the name of a straight line, this line right here. Okay, your line means and you want the math is blue, you want the dollars be red one. Okay, okay. So then and you just say yes, so okay, unknown data, right? These are unknown data that the model has not seen yet, right? So it's this is not part of the training, right? You're saying to me novel, right? Take them new data and yes, my money and you classify garbage, right? Okay, so and then let's see, as I said, your machine learning could benefit Kaneda, so it can generalize to much larger data set in many more dimensions, right? So that's where the utility of this the machine learning comes in, right? Okay, and then let's see. Just the I gave you that example of X-ray. Right? X-ray is very good. Let's see, it is the by the way, we're using machine learning all the time, right? And on the web, right? We're using machine learning, right? The editor was the Facebook also, emails also, machine learning. I mean, some kind of an AI machine learning to use by right? Let's see, for example, spam. Spam emails कसरी हुन्छ भन्दाखेरि so spamको विभिन्न फिचर्सहरू बनाइन्छ अनि जस्तै फर इक्जाम्पल नर्मलाइज काउन्ट इम्पोर्टेन्ट गर्छ जस्तै हाई प्राइस यस्तो यस्तो हुन्छ नि सो यस्तोहरूको होइन फिचर्सहरू बनाइन्छ अनि त्यसको लेभल हुन्छ स्प्याम अर नट स्प्याम है अनि के भन्छ भन्दाखेरि ट्रेनिङ सेटमा चाहिँ है म्यानुअली हामी के गर्छौँ भन्दाखेरि त्यो फिचर्स हुन्छ स्प्याम हो कि होइन है सो त्यो चाहिँ हामीले मान्छेले नै गर्छ त्यो लेभलिङ गर्यो अनि मोडल बनाए मोडलमा त्यो डेटा पठाएर हैन फिड गरिदिएर ट्रेन गर्यो अनि त्यसपछि नाउ कुनै पनि नयाँ इमेल आयो भने इट क्यान टेल वेदर इट्स स्प्याम अर नट है विच इज त्यसले गर्दाखेरि आजकल हाम्रो स्प्याम हाम्रो इनबक्समा है स्प्याम आउँदैन नि है सो कारण त्यो बिकज देयर इज दिस spam filter जुन भनेको machine learning, supervised machine learning हो त्यो है okay. All right, so let's look at another one, regression, right? Predicting continuous levels. Right? Regression is also key. It's a supervised machine learning problem, right? Supervised machine learning, and then the levels are what? Continuous. Okay. In contrast with the discrete levels of a classification algorithm, let's look at regression, which has continuous quantities, right? Continuous levels. Right? So look at this example. It's the S-man. The X-ray. Still, we again have how many? Two features. Right? Feature one, feature two. Right? There are features, right? And then what about the labels? Right? Labels are the discrete chain. It's continuously. Continuously, let's go continuous this go values. Right? Color value, the label value represent. So I mean, say look at the color. Color is gradually shifting, gradually changing, right? Gradually changing. Okay. So when you say infinite number means a lot of them, right? So this might discrete China, right? So this is an example of continuous level data, right? Levels that are continuous values, right? Okay. So okay, this thing you can see there. It is a two-dimensional data. Right? There are two features, as you can see, X and Y, feature one, feature two. Right? Okay. And then as with classification, we have two-dimensional data. That is, there are two features describing each data point. Right? The color of each one represents continuous level for that point. Right? Okay, so अब चाहिँ हामी के गरौँ भन्दाखेरि अब यसमा चाहिँ कलरबाट आयो हैन so यसलाई हैन so what we can do is like 3D projection 3D मा लैजाउँ what we can do is feature 1 feature 2 छँदैछ है अब लेभल चाहिँ कलरमा लेभल छ है कलरले लेभलको भ्यालु रिप्रेजेन्ट गरिरहेछ राइट भनेपछि त्यसलाई अब हामी त्यसमा हैन त्यसलाई हामी के गरौँ भन्दाखेरि जुन त्यो लेभल छ नि है त्यसलाई पनि स्पेशल डिमेन्सन दियो के है स्पेशल भनेको स्पेसमा SPATIAL स्पेशल है स्पेशियल डिमेन्सन दियो के त्यसलाई है त्यसले गर्दाखेरि हामीलाई भिजुअलाइजेसन सजिलो हुन्छ हैन अब हामी के गरौँ भन्दाखेरि त्यसको भ्यालु अनुसार है त्यसको भ्यालु अनुसार हामी के गरौँ भन्दाखेरि त्यसलाई जेडमा है XY यसलाई यसरी सम्झौँ कि दिस इज XYZ है okay let me quickly show you that right let me take a snip I can show you right so let's see new just give me a second let me crop this right okay right here okay all right here we go okay अब यसमा just quickly take a second. So what we can do here is see so यसमा अघि के थियो feature 1 feature 2 and color right that's it 3 dimensional अब हामी यसलाई 3 dimensional मा गयौं अब हामी के गर्यौं भन्दाखेरि let's say feature 1 भनेपछि यता भयो हैन so this is feature 1 rather let's use red color right that contrast राम्रो आउँछ त्यसले हैन यसो गरौँ है so यसो सम्झ्यौ के so now feature 1 भनेपछि यो feature this is x भयो हैन feature 2 y भयो अनि यो z है x y 3 dimensional है 3 dimensional मा भएपछि अब यो जुन भुइँ छ नि जुन फ्लोर छ है this floor चाहिँ के भयो भन्दाखेरि जुन अहिले हामीले देख्यौ नि है 2 dimensional data this one right here so this is it यो चाहिँ floor हो hey this is the floor यसको floor xy है xy हैन so this is the floor अब हामीले के गर्यौं भन्दाखेरि यसको जुन लेभलको भ्यालु छ है त्यो अनुसार यसलाई चाहिँ z मा प्रोजेक्सन गर्यौं है z मा है भनेपछि यसको भ्यालु अनुसार जति यसको भ्यालु छ त्यसको त्यसलाई हामी z मा है माथि प्रोजेक्सन है उठाउने है माथि उठाउने है भनेपछि फर एक्जाम्पल let's say this point right here and यो point छ हैन यसको भ्यालु जति छ नि त्यो अनुसार हामी z मा हामी उठाउँछौं है okay so just say अब यो पहेँलो छ it's really big हैन so एकदम ठूलो छ क्वान्टिटी so यस यो हैन यसलाई चाहिँ हामी त्यति नै जति हाम्रो त्यसको भ्यालु छ त्यही अनुसार नै त्यो z मा z एक्सिस मा जान्छ right okay does it make sense बुझिराख्नु भएको छ
हजुर सर
okay अब let's see अब यो भएन so you guys understood यो डायग्राम बुझ्नु भयो तपाईहरु हैन अब हामीले के गर्छौं भन्दाखेरि अब यो भएपछि हामीले यो किन गर्यौं you'll see that in a moment है किन हामीले यो गर्नु पर्यो भनेर है अब यो भइसकेपछि के भन्दाखेरि अब हामीले के गर्न सक्छौं भन्दा यसमा अब मसिन लर्निङ अल्गोरिदम अघि पहिला जुन क्लासिफिकेसन केसमा थियो नि हैन क्लासिफिकेसन केसमा डिस्क्रिट दुईवटा लेभल थियो इट वाज अ सिम्पल प्रब्लम है अब रिग्रेसनमा देयर आर सो मेनी डिफरेन्ट भ्यालुज हैन अनि मसिन लर्निङ अल्गोरिदमले बेसिकली के गर्छ भन्दाखेरि उले चाहिँ हैन उले चाहिँ व्हाट इट डज इज दिस उले चाहिँ के गर्छ भन्दाखेरि यसमा उले चाहिँ एउटा प्लेन फिट गर्छ है दिस इज अ प्लेन भनेको पाता के इट्स लाइक पाता ओके र प्लेन फिट गर्छ बुझ्नुभयो ओके सो यो डेटा जस्तै हाम्रो 2 डिमेन्सनल केसमा के भयो जस्तै 2 डिमेन्सन यदि तपाईको 2 डिमेन्सनल तपाईको कन्टिन्युअस लेभल डेटा छ हैन यस्तो खालको है छ भने व्हाट डु यु डु भन्दाखेरि वी फिट व्हाट अ लाइन हैन यसमा हामी लाइन फिट गरिन्छ है ओके तर 2 डिमेन्सनमा जस्तै 2 डिमेन्सनमा 1 डिमेन्सनको लाइन फिट हुन्छ हैन त्यो बाउन्ड्री भनौं न एक्चुअली हैन बाउन्ड्री भन्दा पनि त्यो फिटिङ है फिटिङ हुन्छ है यो क्लासिफिकेसन होइन त्यहाँबाट बाउन्ड्री हुँदैन अफकोर्स यो चाहिँ रिग्रेसन प्रब्लम है रिग्रेसनमा यो चाहिँ फिटिङ होइन बेस्ट फिट लाइन है यो चाहिँ बेस्ट फिट लाइन हुन्छ होइन तर त्यस्तै गरी हामीले चाहिँ अब जस्तै 3 डिमेन्सनमा पुग्ने बित्तिकै के हुन्छ भन्दाखेरि प्लेनमा जान्छ है जति डिमेन्सन भयो त्यसको -1 हुन्छ कि यसको यो चाहिँ 2 डिमेन्सनल प्लट छ भने होइन यसको बेस्ट फिटिङ के हुन्छ whatever that is त्यो चाहिँ के हुन्छ भन्दाखेरि 2 - 1 डिमेन्सनको हुन्छ भने चाहिँ लाइन हुन्छ है 2 डिमेन्सन प्लटमा 1 डिमेन्सनको भनेपछि यो चाहिँ के हो यसमा के भयो भन्दाखेरि 3 डिमेन्सनको 3 डिमेन्सनमा हाम्रो के भयो भन्दाखेरि ओके यो 3 डिमेन्सनमा हाम्रो 2 डिमेन्सनल 3 - 1 2 है 2 डिमेन्सनलको के आउँछ प्लेन आउँछ जस्तै 4 डिमेन्सनल छ भने 3 डिमेन्सनको हुन्छ त्यो है यो हाइपरप्लेन भन्छ यसलाई हैन यसलाई हाइपरप्लेन भन्छ सो त्यो हाइपरप्लेन छ नि जति त्यसको डिमेन्सनको डेटा हुन्छ हैन त्यसको -1 हुन्छ कि बुझ्नु भयो ओके सो यो यसरी बेस्ट फिट प्लेन है जुन प्लेनले चाहिँ हैन सबभन्दा बेस्ट डेटाहरुलाई फिट गर्छ है त्यस्तो खालको प्लेन यो मसिन लर्निङ निकाल्ने भनेको यो प्लेन दिने हो के अनि यसको प्लेनको प्यारामिटर्स दिन्छ भने है ओके यहाँसम्म बुझिराख्नु भएको छ
Yes, sir.
छ है ओके यसमा कन्फ्युजन छैन ओके के छ भने सोध्नु होला है ओके सो अब चाहिँ के भन्छ भन्दाखेरि दिस इज वाट ओके सो अहिलेको यसमा जस्तै क्लासिफिकेसन केसमा हामीलाई लाइन दिएको थियो हैन अब यो रिग्रेसनमा हामीलाई चाहिँ के दिन्छ हामीलाई प्लेन दिन्छ है अब यो प्लेन दिइसकेपछि हामीले के गर्न सकिन्छ भने कुनै एउटा नयाँ डेटा दियो हैन अब हैन नयाँ डेटा आयो भने नयाँ डेटामा जुन कि यो त्यो मसिन लर्निङलाई ले देखेको छैन है त्यस्तो डेटा छ है so let's say for example let's say we have this data right here है यो डेटा छ भनेपछि यसले के गर्छ भन्दाखेरि यसलाई यहाँबाट सिधा प्रोजेक्सन गर्छ प्रोजेक्सन गरेर हैन ओके प्रोजेक्सन गरेर अनि जानेर त्यो प्लेनमा हिट गर्छ नि है जस्तै यहाँनिर हिट गर्यो है यहाँनिर हिट गर्यो प्लेनलाई हिट गर्यो भनेपछि अब त्यसले के प्रेडिक्ट गर्छ भन्दाखेरि के प्रेडिक्ट गर्छ होला त्यसको आन्सर के आउँछ करेक्ट आन्सर के आउँछ आन्सर प्रेडिक्टेड आन्सर करेक्ट हैन प्रेडिक्टेड आन्सर के हुन्छ भन्दाखेरि जेड कम्पोनेन्ट है त्यसको प्रेडिक्टेड आन्सर के हुन्छ भन्दाखेरि यो जुन जेड कम्पोनेन्ट छ नि है यही नै प्रेडिक्टेड आन्सर है उसको प्रेडिक्सन के हुन्छ है जस्तो जेडको जुन हाइट छ नि है बुझ्नु भयो इज इट मेकिङ सेन्स
हजुर
right okay all right so okay so okay so any questions so far no
sir.
okay takes it all right so it's a regression is the hyperplane बनाउँछ hyperplane say अब यो हैन यो 2 डिमेन्सनको डेटा थियो 1 डिमेन्सन प्लस लेभल जोडा 3 डिमेन्सन भयो यस्तो त अब 1000 डिमेन्सनको होला हैन जस्तै 1000 डिमेन्सनको छ भने हाम्रो हाइपरप्लेन कति डिमेन्सनको हुन्छ 999 हैन त्यति डिमेन्सनको हुन्छ भनेपछि त्यो त इट्स माइन्ड बगलिङ है इभन भनौं न इभन 5 डिमेन्सन छ भने 4 डिमेन्सनल हाइपरप्लेन हुन्छ है ओके सो आई मीन ओके एनीवे so this is how it works right okay so अब त्यो भएपछि हाम्रो के हुन्छ भन्दाखेरि अब you can see there अब यो चाहिँ अब नयाँ डेटा है न्यू अनसिन डेटा यो अनसिन डेटा छ अननोन डेटा अनसिन डेटा बाइ द मोडल अनि यसलाई चाहिँ हामीले के गर्छौँ भन्दाखेरि अब मसिन लर्निङ मोडलमा त्यो जुन हाम्रो ट्रेन मोडल छ है ट्रेन मोडलमा पठाएपछि के हुन्छ भन्दाखेरि यसले हामीलाई त्यो लेभल दिन्छ लेभल चाहिँ यसले केमा दिइरहेछ भन्दाखेरि अफकोर्स त्यो प्लेनको हैन प्लेनको इन्क्लिनेसन अनुसार है प्लेनको यसलाई फेरि हामीले 1 डीमै लैजाने भने त्यो कलरमै इन्कोड हुन्छ नि त इन्फर्मेसन त हैन यो प्लेनलाई हामी यहाँ फेरि ब्याक टु दिस फ्लोरमा हामी प्रोजेक्ट हैन फ्लोरमा प्रोजेक्ट गर्यो भने चाहिँ फेरि यसलाई स्पेशलबाट हामी फेरि स्पेशल जुन यो छ नि स्पेसको जुन क्वान्टिटी छ त्यसलाई चाहिँ हामी कलरमा फेरि इन्कोड गर्न सक्छौँ भन्दाखेरि यहाँ जस्तो फेरि you see this continuous shift change in color है यो चाहिँ सेम यही प्लेन हो यो प्लेनलाई चाहिँ हामीले के गरेको भन्दा फेरि यो फ्लोरमा लगाएर यो 2 डिमेन्सनमा त हेरिरहन्छ है अनि यसको जस्तै यसको यो प्लेनको हैन यो इन्क्लिनेसन अनुसार जस्तै यता इन्क्लाइन छ नि यो हैन यसको यता यता बढ्दै बढ्दै गएको छ भनेपछि यसको कलर पनि त्यही अनुसार शिफ्ट हुँदै जान्छ यतातिर है okay so this is how it works okay all right so any questions so far
No, sir.
no okay all right अब यसमा त्यही यही जस्तै अब यसमा अब यो त सिम्पल केस भयो हैन सिम्पल यो त हामीले भिजुअलाइज गर्न सकियो है यो त एकदम हाई डिमेन्सन लट अफ डेटा है सो यु क्यान हामीले गर्न सक्दैन है they say as with classification example this may seem rather trivial in a low number of dimensions right? But the power of these methods is that they can be straightforwardly applied and evaluated in this case of data with many features means high dimension high features जति धेरै features भयो त्यति dimension हैन okay all right so this is similar to classical computing distance जस्तै तपाईलाई we use the practical applications भनौं हैन you want to compute the distance to galaxies हैन galaxy कति टाढा छ galaxiesहरु हैन so हामीले हरेक चोटी हामीले scientific method प्रयोग गर्दाखेरि हैन it's too cumbersome and then it's too costly right so त्यसको सट्टा हामीले के गर्न सकिन्छ भन्दाखेरि हामीले few known galaxies र उनीहरुको distance है जस्तै उनीहरुको featuresहरु so यसलाई feature engineering पनि भनिन्छ है so feature engineering so तपाईले त्यो features कसरी चुज गर्नुहुन्छ हैन त्यसले पनि determines the the performance of your model okay जस्तै यो केसमा के गर्न सकिन्छ जस्तै फिचर्सहरु के हुन सक्छ जस्तै one of the features could be brightness of each galaxy है त्यसको brightness कति छ हैन it's one of several wavelength colors है अनि त्यसरी so you can choose different features है त्यसको featuresहरु अनि त्यसको त्यता डेटा हुन्छ नि है सबै डेटा हुन्छ है अनि त्यसबाट चाहिँ तपाईले त्यो featuresहरु चुज गर्नुहुन्छ and then level चाहिँ distance or redshift of the galaxy and label change distance distance which is a continuous quantity हो त्यसले गर्दा regression लगाउनु पर्यो यसले हैन अनि त्यो गरेपछि के हुन्छ भने maybe you have say 500 galaxies हरु छ उनीहरुको सबै featuresहरु छ and you have levels कति टाढा छ है भनेपछि you can build a model machine learning model train it with that data अनि कुनै एउटा नयाँ galaxy जसको distance हामीले थाहा छैन भनेपछि त्यसको डेटा यसमा प्लग इन गरिदिएपछि अथवा त्यो मोडलमा पठाइदिएपछि के हुन्छ भन्दाखेरि it gives you the estimated distance है which is हैन exact चाहिँ आउँदैन of course but very close आउँछ है त okay so okay so त्यस्तै गरी we can do clustering है clustering we have already seen clustering clustering exactly clustering the छैन होला or गरे जस्तो लाग्छ है clustering गरे हो के means
classification गर्छ cluster गर्छ unsupervised गरेको छैन
हैन त्यो हामीले matplotlib गर्दा clustering गरे जस्तो लाग्छ मलाई clustering गरेर जस्तो लाग्छ है त्यो उसमा के रे IS data setमा अनि पहिला हामीले dimensional reduction गरेर अनि clustering गरेको है if you go back to the notes much fun IS data set हामीले clustering गरेको थियो नि है maybe you don't remember now but if you go back to the notes that's fine okay so anyway so the classification and regression illustration we just looked at our examples supervised right obviously we're entering the unsupervised zone right let's talk about unsupervised right unsupervised learning involves models okay that describe data without reference to any known levels right then we don't give the levels right so under unsupervised the main difference ke right supervised and unsupervised supervised we give the levels in the training data right unsupervised we do not give the training data rather we do not give the training levels of the training data right correct answer then okay so everybody is clear on this right it's a clear on this right okay all right yes okay so one common use of okay is the clustering is an example of unsupervised learning, just like we do not keep the levels, but it figures out the groups, right? Groups. Okay. All right. And data is assigned to some number of discrete groups. Right. Let's look at this. It's the how data. Right? We're given this data, same thing. Right? We have feature 1, feature 2. Right? They are data. They are features. Right? But we don't know the levels. Right? Just your point one, right? Your point यता पनि हुन सक्छ, यता पनि हुन सक्छ. यो point हैन, यहाँ पनि हुन सक्छ, यहाँ पनि हुन सक्छ. हैन, यो ग्रुपमा हुन सक्छ अथवा यो ग्रुप. So हैन, so अब यसमा चाहिँ हामी के गर्न सक्छौँ भन्दाखेरि we can use a clustering algorithm and then it will give you the levels, right? At least the group level, right? Group कुन चाहिँ ग्रुपहरु दिन्छ त्यसले. ग्रुपमा छुट्याइन्छ के उसले. Right? Let's look at that. Cluster, okay, group one, right? Okay. All right. So by eye, it is clear that it's of course, I'm but it's the obvious my board, 2-dimension by and more or less. Yes, 4D by data 4D must have them. This is there's no way. The case, right? Clustering algorithms help. Right? Okay. All right. We can use k-means algorithm, right? K-means algorithm, right? We can find the clusters, right? The k-means, it gives you this nicely, right? You're a group, you're a cluster, or cluster. There are 4 clusters, and you can see there are 4 clusters, right? And then you can, you didn't give that. Let's say, yes, I mean, yeah, right? Actually, code my right? So I mean, so it nicely it gives you gives you these clusters, these groups, right? Okay. It might seem like a trivial exercise in 2 dimensions, but as our data becomes larger and more complex and high dimensional, so clustering algorithms can be employed to extract useful information from the data set. Right? So this is clustering, which we have done in code as well, right? And key means like algorithm, right? So, okay. That probably could not matter. Okay. Oh, this thing is dimensional reduction, which we have done. This one as well. Dimensional reduction. हामीले कति बेला गरेका थियौं अथवा कुन डेटा सेटमा गरेका थियौं
dimension map algorithm use गरेको थियो कुनमा चाहिँ गर्नु
exactly है कुन चाहिँ डेटामा do you remember they were I think I mean irisma गरेको छ नि क्या maybe उसमा गरे जस्तो लाग्छ iris पनि गरे क्या irisमा अनि त्यो digit data set मा 64 dimensional हामीले 2 dimensional ल्याएको थियौं नि याद छ
digit data
right yes है digit data set मा अनि हरेक digit के छ भन्दा how many dimensions कति थियो हरेक digit कति dimension को थियो 64 8 by 8 थियो त्यसलाई फ्ल्याट गर्दा 64 हुन्छ हैन 64 dimensional data लाई हामीले कति dimension मा ल्याएको थियौं
1 dimension 2 dimension
2 dimensions right yes 2 dimensions right x or y so ताकि त्यसलाई scatter plot x or y मा scatter plot गर्न सकियोस् हैन हामीले त्यसलाई ल्याएर 2 dimension मा ल्याएर हामी प्लट गरेर अनि त्यसको लेभल पनि राखेर हेर्दाखेरि ठ्याक्क क्लस्टरिङ भयो जस्तो गएर ठ्याक्क त्यो ग्रुपिङ भएर बसेको थियो हैन okay so dimensional reduction is another example of an unsupervised algorithm with in which levels or other information are inferred from the structure of the data itself. We do not provide. Okay? We do not provide the levels or other information. We just give features, just the features. Okay? And it has to figure out on its own. After to figure out also. Okay? So it has to infer from the structure of the data. Okay? So dimensional reduction is a bit more abstract. Okay? It seeks to pull out some low dimensional representation of data that in some way, so here's the key. Okay, the key part. It preserves relevant qualities of the full data set. Means, let's say, 2-dimensional, say, lower dimensional, but it is still the information, minimal information loss. The relationship, they are still intact, more or less. Okay, okay. So it preserves those relevant qualities of the full data set. Okay, so that is the key. Okay, so different dimensional reduction routines measure. Okay, so we have already seen ISMAP, PCA. I think PCA. I'm not sure. Right? So principal component analysis. So algorithms are. Okay, we can use those to reduce the dimension of high dimensions data, high dimensional data to a low dimensional subspace. Right. Okay, so likewise, you can do for another example here. It's the calculate data set. Right. So means of LIM, we can put it in some kind of so ISO map we can do. It's the calculate. LIC one dimensional right. Okay, it's the radial. So anyway, so summary. What is the summary? The summary is so what is supervised? Supervised Q lady. We can then predict levels based on level train. So the data, the training data is labeled. Okay, supervised the training data is labeled. Okay, okay. This supervised there is classification, regression. Okay, classification what is classification? Levels are के हुन्छ कस्तो खालको हुन्छ लेभलहरु discrete हुन्छ regression ma
continuous
regression continuous. It's very good. Unsupervised learning ma के हुन्छ
table provide गरिदैन
very good. Unlabeled data है. Okay, and त्यसै गरी clustering ले के गर्छ है यसले identifies distinct groups है. Dimensional reduction ले के गर्छ है यसले चाहिँ के गर्छ low dimensional higher dimensional low dimensional lower dimensional representation of the data. Right? Data. Right? Okay, so pretty much this is the overview of machine learning and qualitatively. Quantitative it's all intuitive, qualitative. Right? Okay, so now we actually we'll go to scikit-learn. Scikit-learn, which is an excellent package, the most popular package, machine learning package for Python. Either. So let's do that. So what I'm going to do is, let me show you. Let me see. It's not here. Right. Okay. I think I had it here. 1 second. Sorry. Close that. Let me close. Okay, so I'm going to do this. अब तपाईहरुले के गर्नु भन्दा मैले अस्ति नै एकचोटी एउटा इमेल पठाएको छु नि है त्यसमा I've given you the GitHub repository है GitHub repository मैले पठाएको तपाईहरुलाई याद होला है so त्यसमा please go there and of course you need to download that मैले कसरी डाउनलोड गर्ने त्यो पनि भनेको छु हैन so you can download that repo है repository download गरेर अनि that's what I've done here right so where's it let's see okay so this is that repo right त्यसलाई zip मा आउँछ zip लाई unzip गर्नु पर्यो unzip गरेपछि यसरी Python data science handbook master भन्ने आउँछ so this is your repo है अब यो repo लाई मैले Jupyter मा खोलेको मात्रै हो भने चाहिँ repo भित्र notebooks छ है notebooks छ okay and यसमा we'll start यो सबै जति पनि हामीले यो भन्दा अगाडि जुन data science part मा गर्यौ नि so most of these are coming from here है this book okay so this one machine learning chapter 5 यहाँ start हुन्छ okay so जुन हामीले भर्खर गरे this is this here what is machine learning है हामीले भर्खर यो सिक्यौं है So let's look at this one, right? About scikit-learn, right? Let's look at introduction to scikit-learn, which is the most popular package, right? Machine learning algorithms package, right? Okay, so there are several Python libraries which provide solid implementation of a range of machine learning algorithms. One of the best known is scikit-learn, a package that provides efficient versions of a large number of common algorithms. And it's really easy to use, by the way, right? Okay, the scikit-learn is characterized by clean, uniform, and streamlined APIs, okay, as well as by very useful and complete online documentation. The benefit of this, okay. So if you know how to use one algorithm, your algorithm training you can pretty much do any, you can use any other algorithm. The uniformity the patterns are uniformity. Once you know how to use one algorithm in scikit-learn, you can pretty much use any other algorithm in scikit-learn. Right? Okay. All right. So this okay. Let's see. Okay. So first one, of course, is always about data. Okay, without data is the fuel. I know the model when it goes to cars, a gadi. I know model when it go gadi. Data is the fuel. Fuel now we can gadi also. Gadi gadi was if you do not have fuel, then the gadi the kami just like that. So data is what fuels, what drives, and what fuels the model. So let's see. Scikit-learn expect also. It expects data to model a fit conclusion data science. Right? It expects that to be in a particular format. Or a particular format. The format right? So let's see how we can do that. Right? Machine learning is about creating models from data, as we know, as we saw. Right? Okay, so let's discuss how data can be represented in order to be understood by the computer rather by scikit-learn package. Right? So it's my data as a table. Right? So most customer data is a mostly two-dimensional, right? Mostly tabular form. Right? Data itself. Right? Data itself. Say you the two-dimensional data on there. The data, whole data, whole data. Rows, columns, right? Two dimensions. But every point that is a higher dimension, right? Just the point kati dimension, features, features, 4 dimensions, right? Point say 4 dimension, as a whole data is 2 dimension, right? Okay, rows, column, right? That's it. 0 dimension, right? Okay. So most of our data sets are two-dimensional data. As a table, we can visualize or look at this or represent it as in the form of table. Right? Table. You have seen this a lot. Right? You have seen this a lot. No need to go through that. Of isma given of n samples or n features. Right? What is n sample? N samples when you given. Now let me quickly. That's good enough. Yeah. So let me quickly do this. This is my keyword. I'm going to take a new snip and samples and features from a keyword. Okay. So let's figure that out. Okay. So of n samples from a keyword. So these are called samples. You individual tiny. So in your case, these are called examples or samples. Given in your line, samples or examples. Examples or samples. Yes, right. So over yesma, and if you n samples, n underscore samples, okay, and n underscore sample, number of samples. N sample n number of samples kati bhayo त्यसमा भनेपछि 5 वटा छ right? Okay, n sample and n in your queue. What are these in your queue? What are those?
N features.
Features. Basically these are features. In your features. So features अनि n features भनेपछि के भयो त n features भने के भयो number of features है भनेपछि यो केसमा what is the number of features n features 4 है यसमा किनभने 1 2 3 4 है चारवटा फिचर्स छ नि त सो त्यसले गर्दाखेरि now you're clear about n underscore features र n underscore sample है यो terminology याद गर्नु है त so because we're going to use this okay so n samples and n features okay so okay n samples and n features okay so अब त्यस्तै गरी हाम्रो के हुन्छ भन्दा feature matrix भन्ने हुन्छ so feature matrix भनेको के भन्दाखेरि this matrix यो चाहिँ matrix हो नि है this whole thing is a matrix है two-dimensional matrix हैन whole data हेर्नुस् त it's a two-dimensional matrix let's see हैन यो चाहिँ त two-dimensional matrix हो नि त है okay matrix अनि यो चाहिँ अब यो whole thing is a matrix है अनि यसलाई हामीले दुईवटा भागमा छुटाउन सकिन्छ कि rather यसो है त I'm going to stop it right here and please join back है त okay I'm going to end it right here